The idea that there are more planets than stars is just incredible to think about. We know that there are billions and billions of stars in our galaxy, and to think that there are even more planets, it completely changes our thinking and our place in the universe.
I remember being a child lying down in the summer grass, looking up into the night sky, wondering whether there were planets orbiting the stars I was looking at, with beings on the surface of their planets looking in our direction, asking the same question. And so what more planets than stars means to me is that we have the hope to eventually find out whether the answer to that question is yes or no.
For me, it's been transformative in that it has really catalyzed a third pathway for the search for life in the universe, or the search for life beyond Earth. You know, before Kepler, we had SETI searches to listen for technosignatures in the galaxy. We had solar system exploration that was searching for life, and hiding in niches in the solar system, maybe in a subterranean cave on Mars or underneath the ice on Europa or Enceladus. But the third pathway was opened up, I think, by the sudden realization that the nearest potentially habitable planet could just be a stone's throw away, that there are tens of billions of these planets in our galaxy alone.
I think that one of the things that was most amazing about the Kepler mission was after the two reaction wheels died, and I was convinced that the mission couldn't continue because nobody had ever considered operating Kepler with only two reaction wheels. And the brilliant scientists and engineers who are working on Kepler came up with the scheme that we've used successfully for several years to operate Kepler in its K2 mission, of using the pressure from the sun's light to hold Kepler in place instead of a third reaction wheel. I mean, that just makes you think that, when something breaks on a satellite, well, we can figure it out. We can make it work. That's fabulous.
Ever since I was a little kid, I was interested in space. I wanted to be an astronaut. Things like the glasses meant that I couldn't do that. So I became an astronomer instead. And when the opportunity to join the Kepler project to discover new planets around other stars, I grabbed that immediately. I really wanted to do that. And it's been a really inspiring mission because we got to discover, all of this new stuff that nobody ever saw before.
Growing up, I read a lot of science fiction and watched a lot of science fiction films. In all of those movies and books, it was taken for granted that planetary systems were common. So I think I grew up with that expectation. But until the Kepler mission, there was no basis to assume that planetary systems were really that common. With Kepler, we've hinted that perhaps some of those science fiction stories could become reality in the future.
By studying this universe, we ultimately start to understand our place in it and understand where we come from, what our future will be, and why we exist, which I think is one of the most fundamental questions we can ask as a human species, is where does all this stuff come from? And Kepler has provided key answers by answering the fact that planet Earth is not alone. There's planets everywhere in our galaxy.
There was no buzz about exoplanets when we really launched Kepler, but after its results, I think everyone, if you had to stop and talk to someone on the street, they'll be able to talk to you about what they think about exoplanets and what they know, and that's a real difference.
I saw this an article recently, and it is depicting a cave wall painting from 18,000 years ago, and it showed, for example, the first time that our ancestors were thinking abstractly, and this cave wall painting was fascinating. It showed what their everyday life was like, and they were hunting, they were gathering, and this is how they existed. But in this cave wall painting, there was some unusual articles in the painting, and they were stars. And it's sort of one of the first times we have evidence that our ancestors were actually looking up at the heavens. They might have known what they were looking at, but fast forward thousands of years to the 21st century, and here we are with a machine that is now probing those stars, allowing us to find planets.
Most people in fact, everybody I work with on the project, This wasn't a 9-to-5 job for them, and they wouldn't have lasted if it had, because this mission, this is 8, 10, 20 years of some people's lives. What kept them motivated is they were, everybody was passionate about the science. They were excited about finding those exoplanets.
We found so many fantastic and exciting planet systems out there, none of which look quite like what we have at home. And for me, the most exciting part of all of this is not just the sheer number of planets, we found thousands, but the fact that we've found so many varied planets. We've found massive, puffy, hot Jupiters that have orbits shorter than Mercury. And we found mini Neptunes, where we don't know if they are solid and rocky or are they puffy and gassy. We found brand new forming planets and old planets too. And I'm really excited about the zoo of variability in planets that we've found.
I think it's a great discovery. I'm glad we found that. But the reason it's not a surprise is you see this in everyday life. Go out into your gravel parking lot and look around at rocks. There's more small rocks than big rocks. Go look at birds. There's more small birds than big birds. Go look at bugs. Anyway, there's always more small things than large things. And for us as humans, that's great, because small planets, rocky planets like the Earth, are what we can call home. So it's fabulous that there's more planets than stars.
Before Kepler, we knew exoplanets existed, and we suspected they were common, but now we know they're common. And once you know they're common, that really opens up the possibility to have missions like TESS, where you look for planets around nearby stars that are good for follow-up, or some of the ground-based instruments right now that are working on doing initial direct imaging of exoplanets. Some of the technology going on that 20 years from now might be able to directly image and measure the spectra of an exoplanet. We needed to know that planets were common before we could invest in those things. And the fact that we now know they're common and all of those things are starting to happen is really exciting.
This is the golden age of exoplanets. Kepler has given us this tremendous data set, this gift that we can continue studying for decades. And all in the meantime, there are new missions, new telescopes, and new technologies that are coming along, which are going to help us learn even more in different ways and go beyond what even Kepler could do.